we continue to calculate factorial, and in our previous video I showed you how to use loops to calculate it, but another solution is to use a recursion. What it means is that we would need to put the logic of calculating factorial into a function, and the function needs to return a value after each call. And we need to call the function from within its body until the base condition is met. Now in our case, the condition is that the n value equals 1. So until this condition occurs, we will call the function and pass n parameter to it. Now the pattern that factorial follows is quite simple. You can see that the numbers are sequential. In other words, we multiply a sequence of numbers such as 1 times 2 times 3 times 4 times 5, etc. So to simulate this with recursion, we will simply pass the n value less 1, so n minus 1. That way, the n value keeps decreasing until it equals 1, and that's the condition when the recursion stops. So let me show you how it looks when coded. We have our loops, so now let's calculate the factorial using recursion. So I'm going to create a function, and I'll just call it calculate recursion, and it needs to return an integer. So just like before within the loop, we will pass the n value. So if the user wants to calculate the factorial of 5, we will simply pass 5 as n. And within our body, the first thing we need to do is check for the base condition. So the base condition for factorial is when n equals 1. Remember, factorial starts calculating from 1. We don't use 0, we'll start from 1, then 2, then multiply by 3, by 4, and so forth. So if our n equals 1, we will stop the recursion and we will simply return 1, because the factorial of 1 is 1. So if we pass 5, this condition is skipped because 5 does not equal 1. Instead, what we are going to do, we're going to call the calculate recursion again and pass another value for n. That's going to be the n minus 1. So we'll pass the next number, which after 5 would be 4. Then after that would be 3, then 2, and then finally 1, which will trigger this condition and stop the recursion. Now we will call the recursion, and with the result of it, we will multiply it by the n. The same way like we did within the loop. Factorial equals I multiplied by factorial. So to put it in a recursion, we will simply return the n multiplied by whatever value is coming from our calculate recursion. And like I said, we need to pass the n, however, minus 1. If you just pass n, it would never change, so this condition would never be triggered. Basically, you would be in an infinite loop. So what's happening here is the user passes 5. 5 does not equal 1. So we will come over here and call the calculate recursion again. However, now 5 minus 1 is passed. So we will pass n equals 4. Now 4 still doesn't equal 1. So we'll come here again. Now we'll pass 3. And then we'll pass number 2. And then finally we'll pass 1. If statement is triggered. And then we will come back to these calls, and the value returned from the calculate recursion will be now multiplied by n. So all we have to do is go to our main method and simply call this a recursive function. So I'm going to just copy paste because it's going to be the same way, except where it says loop, I will do recursion. So recursion calculation of factorial of n is, and we will call the calculate recursion instead of calculate loop. So again, user passes, for example, 5, and then within our function, we call the function itself, but we'll pass 4, then 3, then 2, and then 1, which ends the recursion and returns the values that we will now display, the ones they are multiplied and added together within our return statement. Alright, so let's run it. So if I do integer 5, you can see that loop 1 and 2 have factorial of 5 equals 120, and so does the recursion. So that's working fine. Let's do one more just to make sure. Let's say 8, and you can see the results are the same, which is correct because we calculating the same factorial just using different methods, but the result needs to be obviously the same. Alright, so now you can see the difference between looping and recursion, and you can see how to iterate within the loop in ascending or descending within our loop here and the loop 2 that we did in previous videos. So hopefully you are now more comfortable with recursion, but if you need a little more practice, in the next video I'll show you another example of loops versus recursion. So I'll see you in the next video.